Let's talk about expanding and condensing logarithms. Expanding means to make bigger, condensing means to make smaller, and there's four really different types of rules we're going to focus on. First one is product, second one is quotient, there's also power and equality. Got a little indicator here of what these rules mean in shorthand. So product goes with addition, quotient goes with subtraction, and powering, we refer to it as the traveling exponent. We'll see what that means a little bit later on. So the first rule we're going to focus on is the product rule. That is when we see multiplication. So multiplication is going to become addition. So they're going to give us log base 3 of 9x. Okay? Now the reason this is product rule is because if I focus on this 9x, it is 9 times x. So however many pieces are being multiplied, that's how many logs we're going to expand this into, because this is condensed right now. We want to expand it out. So I've got 1 piece, 2 piece. So I'm going to expand this into 2 logs with the same base of 3. Now the multiplying, that's called product. That is going to become addition. So we're going to put a plus sign in between these. And I'm going to split this apart, where the 9 goes with the first log and the x goes with the second log. And there you have it. You have expanded using product rule. Let's say there were a couple more pieces in there. So for example, they tell us log base 5 of 6xy. So this time it's 6 times x times y, all part of this log. So it's going to get expanded into 3 logs. So I'm going to write it as 3 logs, all with the same base of 5. Multiply, multiply, multiply. So those multiplies become addition here, because multiplication goes with addition. And then I'll split the pieces, 6, x, and y. So 6, x, and y. And there we go, fully expanded. Now if they told us to go the other way, they gave us an expanded version and they wanted to condense it, we'll just think about going the opposite direction. Log base 7 of 5 plus log base 7 of x plus log base 7 of 4. So I look at them, as long as they all have the same log base, we're going to condense this down into one log term with base 7. I see that it's adding, so adding is going to reverse back into multiplying with these 3 pieces. So it's going to be 5 times x times 4. And we can clean that up a little bit more. That's log base 7. The 4 and the 5 multiply to make a 20. So 20x. And there is condensing it down. Let's take a look at the next one. The next one is going to be quotient rule. So this is when we see division. And division is going to become subtraction. Just like multiplication became addition, division is going to become subtraction. So we've got log base 9, 4 over 7. Same thing, we're going to expand this out. It's going to be 2 pieces, because here's the division, which is going to become subtraction. We've got a top piece and we've got a bottom piece. So it's going to split into 2, the top and the bottom. So log base 9, 4 and 7, they go in order from top to bottom, and then the subtraction is going to come from the division sign here. So subtraction. And there we go. We have expanded out. Let's try another one. Let's say they want us to go the other way. Let's condense it. So log base 2 of 6 minus log base 2 of 2. So this time I see 2 logs. I want to condense that down to 1 log. This subtraction is going to become division, and we work our way from left to right. 6 on top, 2 on bottom. And then if we really wanted to, we can reduce that to just a 3. So not so bad, as long as we remember what goes with what. Let's talk about now the third one, being power rule. And this is what I consider the traveling exponent. So for example, let's say we have log base 2, 8 to the power of x. What is allowed to happen if you have an exponent, in this case the x, it is allowed to travel back and forth. If it's there as an exponent, it's allowed to travel to the front and be written like this: x times log base 2 of 8. And that's usually when you are expanding. The same thing can be said if there is a term in the front. So for example, if it said 3 times log base 10 of 7, now this is allowed to travel up here and become the exponent on the 7. So it would be log base 10, 7 to the power of 3. You see how that exponent moves? If it was as an exponent, it moves to the front. If it was in the front, it moves and becomes the exponent. Now that second one is usually when we are condensing problems. So the exponent is allowed to move depending on where it is. So we're going to see this more of how we're going to see our problems. A combination of everything. So combo problems. So a combination of all rules. There'll be adding, subtracting, multiplying, dividing, exponents, all of it together. So let's say we had log base 3, 12 over 7 to the power of 2. I want to expand this because you see it only has one log, it's already condensed. I want to expand it. But you'll notice a couple things here. I do have division, which is going to become subtraction. But I can't get to that yet because of this exponent that's keeping the parentheses there. So I've actually got to deal with that first. So that 2 is being combined to everything. So that 2 can move to the front here. So let's write that. Log base 3, 12 over 7. Now I really don't need the parentheses anymore. So that 2 is being technically applied to everything. So I'll keep the 2 outside. This log is now going to get split into 2 with subtraction because of that division symbol there. So we have log base 3 minus log base 3. 12 is going to go here, 7 is going to go there. And now there's our fully expanded version of this logarithm. Now depending where the exponents go, we might have to change the order of things. So let's say log base 6, x over 3, y over 4. This time, the x has the exponent of 3, the y has an exponent of 4. They don't both have the same exponent. So here, since there's no parentheses, I am allowed to split it with this division. And the division is going to become subtraction. So we've got log base 6, my first piece is x to the third, minus the bottom piece, y to the 4. And now I can travel these exponents forward, but they only go with the piece that they're connected. So 3 goes in front of the x piece. 4 goes in front of the y piece. And there we go, our fully expanded version of this. Let's try one more of these. Let's say log base 4, 3x, m4, and the whole thing has a 5. So we want to work our way in. There will be division becoming subtraction, but before that, this exponent is going to travel in front of everything. So I'm going to move that 5 first. So 5 is now going to be outside of all of this. And if you can do multiple steps in your head at once, that's perfectly fine. Okay, now I'll split that division into subtraction with a log base 4. The first piece goes here, minus log base 4, m to the 4, still 5 outside. And what they're going to ask you to do is, again, move this exponent, but that's only connected right here. It doesn't go in front of the 3 part. So we got 5 log base 4, 3x minus 4 times log base 4 of m. And what they're going to do is actually look a little bit deeper into this, because what's something we might have skipped out on here? The 3 and the x are still connected by multiplication. So now we're seeing all the different rules involved. So this is still going to expand out to 2 more pieces. So we got the 5, the log base 4 of 3. The multiplying becomes addition, log base 4 of x, and we're still being subtracted that piece at the end. So this is good for now. Technically, if this were to become a multiple choice problem, they would apply this 5 to everything in here. So we're going to go ahead and show you how that looks. That would be a 5 log base 4 of 3 plus 5 log base 4 of x. We're just distributing that 5 in, minus 20 log base 4 of m. So that was a combination of all the rules we've seen. But either way, we sum this up by saying how we know all these rules go together. So I'll take it all the way back to the beginning. Multiplying goes with addition. Dividing goes with subtracting. And the power, the exponent, are allowed to move back and forth depending on where they're located. Equality we'll look at a little bit later, but for right now, focus on which laws, which rules go with each other. All right.